All right, 6.8. Today we are learning how to graph polynomials. Specifically, how to graph polynomials without your calculator. Now, the test we're taking this week, I guess it's not this week, it'll be Monday, Tuesday, you will not be able to use your calculator on some of the test. So the stuff that I've told you that you could use the calculator on, you'll be able to use the calculator on. Stuff like this, you won't be able to use your calculator on. Based on what we did yesterday, I didn't think today's lesson was all that bad. Okay, so just kind of bear with it. It's not too complicated. It really is just using most of what we've already learned in chapter 6 to graph these. So we're just going to use all the pieces. Here are some key items for graphing with no calculator. You're going to find these 4 items, and we're going to practice finding those 4 items, and then on example 2, we'll start actually graphing with those items. So here are the 4 things you need. You need all the real solutions, or zeros, whatever you want to call them. Then you need the solution's multiplicity, how often that solution appears. You need to identify the end behavior, and then find the y-intercept. If you can find those 4 items, you can just plot them out and graph the graph. Now, I do have this end behavior hack that I showed you how to do in yesterday's lesson. But essentially, if you want to find what the leading coefficient is of this kind of long polynomial, you take the negative down with the single x, and then because this is squared, that's a double x, to find out that the leading coefficient is negative x to the 4th. From that, of course, you can decide that, okay, the leading coefficient's negative and the degree is even. And that'll be really important when we determine end behavior today. All right, I'm going to do example A here and then have you guys do example B. So it says find all 4 items needed for graphing. We're not going to graph, but you just need to find all 4 items needed for graphing. So let's do end behavior first. End behavior, we're going to need that leading coefficient, so negative x squared, x squared. Of course, these x's in the squared, x's in the squared, gives me negative 4x. Because it's negative 4x, it's both negative. I don't know why I put 4x. It should be x4. Silly me, x4. Yeah, I'll scribble that out. Negative x to the 4. So it's negative and even. And what does that tell us? Well, the negative tells us what the right-hand side or what the right end behavior does. And since it's negative, we know the right-hand side is going to go down. And even just means that it goes the same direction as the right side. If it was odd, it would go in different directions. So since this is down, then this has to be down, which means it falls to the left and falls to the right. The next thing we're going to do is find the zero and multiplicity. To find the zeros, we take our terms here and set them equal to 0. Our binomials, that is, set them equal to 0, so x minus 2 equals 0, and solve for those. Subtract 1, we get x is equal to negative 1. Add 2, we get x is equal to 2. So one of our zeros is negative 1, and the other one is 2. Next thing we're going to do for each of these is find the multiplicity, and since they're both squared, we know the multiplicity for both of them are 2. The last thing we need to find is the y-intercept, and that's done by setting x equal to 0. And solving for it. So essentially, f at 0 is equal to negative 0 plus 1 squared and 0 minus 2 squared. I'm just getting this equation from the above equation up here and just plugging in 0 and simplifying it down. Negative 1 squared, negative 2 squared. This is going to be a positive 1 because the negative's outside the square. So this will be negative 1 times. But this over here, since the negative's inside the parentheses, this is going to be 4 to give me negative 4 as the y-intercept. This is going to be the point where it crosses the y-axis. All right, you guys find all the things here with letter B. Does it work? Yes. Okay. Did you guys get a chance to do this? All right, so let's go through the end behavior hack that I showed you up there. So this is x, and then this is x squared to give us x to the 4th. At least I got it right this time. So this is both positive and even again. The positive is going to tell us that the right-hand side goes up, and the even is going to tell us that the left side matches the right side, which means it rises to the left and rises to the right. Your zeros are going to come from these 3 binomials. So this one right here, 0 is going to be 1. For this one, it's going to be negative 2. And for the last one, it's going to be negative 1. The multiplicity for the left one is 1. The multiplicity for the center one is 1. And the multiplicity for the last one is 2. For the y-intercept, we're going to set x equal to 0. So this would be 0 minus 1, 0 plus 2, and 0 plus 1 squared. So we just have to simplify that down. Negative 1 times 2 times 1 squared. Negative 1 times 2 times just 1, because 1 times 1 is 1. And then that all just comes out to 2. Negative 2. Negative 2. Okay? All right. Now that we know how to find the things, we're going to learn how to use the things. All right. So we're going to use the key items from this guy right here to graph this thing right here. So we're going to try to graph f at x equals negative x minus 1. I'm just rewriting it from the top. X plus 1 and x minus 2 squared. We're going to try to graph that over here. So the first thing we're going to do is list all the real solutions. Identify all the places that the graph crosses the x-axis. So all of these solutions are these points where it crosses the x-axis. So where's the first place it crosses the x-axis? It crosses it at x equals 1. Where's the second place it crosses? X equals negative 1. And where's the third place it crosses? X equals 2. So it crosses at negative 1 for the center one, 1 for the first one, and 2 for the last one. These values here are where it crosses the axis. The multiplicity determines if the line crosses the x-axis or it does not cross the x-axis. If it's odd, it crosses. If it's even, it does not cross. I'm going to use the word bounce, by the way, because I like the word bounce. But it'll bounce off and go back the way it came if it's even. So if you look at my little example right here, here's some odd multiplicities. It crosses through, and then even multiplicity, it hits it and goes right back from where it came from. So if you look at my example here, this one's going to cross because it has a multiplicity of 1. This one is going to cross because it has a multiplicity of 1. And this one's going to bounce because it has a multiplicity of 2. So if we go to the actual graph right here, notice that negative 1 crosses and 1 crosses, but 2 bounces. It goes whoop and back down. It was on the bottom, hits it, goes back down. Cross, cross, bounce. Next is end behavior. Determine if the left and right side of the graph end behavior is just determining the left and the right side of the graph. So let's go ahead and find the end behavior. We're going to have to find what the leading coefficient is. So negative x, and x squared, which gives me negative x to the 4th. And this is going to tell me that the negative and the even the negative part's going to tell me that the right-hand side's going down, and the evens is going to tell me that the left-hand side matches the right-hand side. But if you look over here on the graph, it did just that. It falls to the both on the right and the left side. So this is the end behavior. The last thing is the y-intercept, identifies where the line crosses the y-axis. And this is where we just go f at 0 equals negative 0 minus 1, 0 plus 1, and 0 minus 2 squared. Negative, negative 1, positive 1, and negative 2 squared. The negative, negative 1, since there's no squared here, that's just going to give me 1. And then right here, this is negative 2 squared, but the negative's inside, so this is going to give me a 4, which gives me a 4. What this number represents is where it crosses the x or the y-intercept. So this is the y-intercept equals 4. That's because it crosses the y-axis at 4. The part that we won't really discuss is like how high some of these dips go. Like how high is this local maximum? How low is this local minimum? That's something we could do in the future. We're just not going to do in this class. All right, so we're just going to kind of estimate how low it goes. But once you get all of the end behavior, the x-intercepts and the y-intercepts, you plot them all out. You kind of slowly just construct the graph. All right, example 2 says find all 4 items and then graph the following polynomials. All right, so let's do this. So end behavior here, negative x squared, x, giving me negative x to the 4th. So this is negative and even. This tells me that the right-hand side goes down, and then the even means that it goes, the left-hand side matches the right-hand side. So it falls to the left and falls to the right. The zeros are going to be -3, -1, and +1. I'm getting those from these binomials, solving what these binomials are. And then I'm gonna talk about the multiplicity of 1, because it's not squared, 2, because it is squared, and 1, because it is not squared. So the multiplicity is 1, 2, 1, which just really means cross, bounce, cross. The y-intercept, this is f at 0, is equal to -0 plus 3, 0 plus 1 put squared, and then 0 minus 1 equals -3, 1 squared, -1. I like to do the squares in its own terms, so -3, 1, -1, which is 3. All right, so now we're going to take all the things and we're going to take it to the graph. First, plotting out the zeros and then the y-intercept all at the same time. So we have a 0 at -3, put a dot. We have a 0 at -1, put a dot. And we have a 0 at +1, put a dot. For the y-intercept, it says that it has a point, it crosses the y-axis at 3. So I put a dot up there. Now, end behavior says that it falls to the left and falls to the right. So I'm going to go to the outside 2 points and I'm going to make it fall to the left and fall to the right. Of course, it's going to angle a little bit out on both sides because that's the way the graph works as, you know, the domain variable continues. All right, now we need to look at, bounces, crosses. So I'm coming up here on the -3 and I have to determine, am I going to bounce off the -3 or am I going to cross the -3? And I go over to the -3 and I say cross. Okay, so I'm going to cross. And then it needs to curve back down to the next 0. And the next one is -1. Is it going to cross or is it going to bounce off of -1? It bounces. So I'm going to come back down to this, and I'm going to curve back up. It bounces. It has to go through the y-axis intercept before coming back down to this last 0, which is at 1. And it looks like it's going to cross. And there we have it. There's your graph. Now, I know you're not allowed to use the calculator, but you can check to see if it matches your calculator. You just don't want to do this on a test. So I'm going to go y equals, clear what you have there, and then just put your equation in there. Negative x plus 3 x plus 1 squared and x minus 1. And I'm just doing this to show you. Like I said, you're probably not going to do that. You're not going to be graph. You're not going to check them. So you hit graph here, and we'll see. Look at that. Does that not match exactly what we have here? Magical. Now again, how high these maximums and minimums go, it looks like I should have made it the same height, and I didn't. But we're estimating it. There are ways to know exactly where it is. We're just not going to do it. All right? I'm just not going to do it in this class. Okay, here we go. You guys try it. See what you can come up with here. Find all the things. Once you have all the things, put the things on the actual graph. bouncing on all three of them, honestly. And she only bounce on that one. All right. Okay, let's get all the things here. So for end behavior, first things first, we got x, x, and x squared to give us x to the fourth. This means that it's going to rise on the right-hand side because it's positive, and since it's even, they're going to go the same direction. So they're rising on both sides. Our zeros are going to be 0 for the first one, 1 for the second one, and -1 for the third. So multiplicity of 1, multiplicity of 1, multiplicity of 2. Cross, cross, bounce. For the y-intercept, it's going to be f at 0 is equal to 0 times 0 minus 1 and 0 plus 1 squared. And 0 times anything is just 0, so it's going to be at 0. All right, so we have 0 at 0, at 1, and at -1. Our end behavior is up on the right and up on the left. So on the left here, when it gets to the 1 here, it's going to bounce. I believe at -1 it bounces, so it has to go back up. Then it has to cross through the 0 and then come back up and cross through the 1. So it should look like that. Cool, cool, cool. All right. Okay, you guys do both of these now. Okay, on the left one, I've already found out that the end behavior looks like this. And it falls to the left and rises to the right. Here are your zeros, but the multiplicity on all of them is 1. And the y-intercept's at -6. So let's go ahead and plot all those out. So we have -3, -2, and 1. And then it crosses at -6 down here. The end behavior goes up on this side and goes down on this side. And for the multiplicity, we're crossing on all of these. So quite simply, we're going to go up like this, cross it, back down. We're going to cross it. We have to go through the y-intercept and then cross again. So cross, cross, cross. All right, on this one, we have -x squared, x. So this is x to the 5th, that is. So we're going to be falling to the right-hand side, and since it's even, we're going to be going in opposite directions. So that means it's going to rise to the left and fall to the right, so it's this guy here. Your zeros are going to be 0, 2, and -1. So 2, 2, and 1. So we're going to be bouncing. We're going to bounce, cross. For the y-intercept is going to be 0 because if one of the zeros is 0, the y-intercept also has to be 0. And that makes sense because this first term is going to be a 0, which means it doesn't matter what these other ones are going to be. It's going to be a 0. Zero, 2, and -1. All right, your end behavior looks like this. And on this side, it's going up. And at the -1, we're going to cross. At 0, we're going to bounce. And then we're going to bounce again at 2. So it looks like that. All right, this example has us trying to identify which of these graphs or equations here match the graphs up here. So it kind of has you do it in both ways. And so you're really just going to have to do what we did on the previous example to determine which ones these go with. And so let's look at the first one right here. Let's do end behavior here first. So we have -2 x to the 3rd. And the right-hand side is going to fall, and since it's odd, it's going to be going in opposite directions. We haven't had to do this on any of the previous ones, but to find the zeros, we're going to have to factor that. So let's factor -2 x to the 3 plus 8x. Squared, that is. And so we need to factor that and find the zeros out. So we're going to factor out, looks like we're going to factor out a -2 and an x squared. And if I factor out a negative 2x squared, we're left with x minus 2 as the other term. So that's just factoring by GCF. So this is one of our solutions is 0 and the other solution is a 2. Then the y-intercept here is going to be y equals where it crosses. So it'll be negative 2 times 0 cubed plus 8 times 0 squared, which is just 0. So the y-intercept's at 0. So we just need to find the graph that does all these things. For the 0 at 0, let's see here, the multiplicity is 2, so it's going to bounce off the 0, and it's just going to cross the 2. So let's find which one of those bounces off the 0 and crosses the 2, and it goes through the 0, and has the end behavior that looks like this. So it's not A, it could be A, or it could be F, because they have that end behavior. They both go through 0, and that goes through 4. I think up here, did I get my wrong 0 here? That should be a 4, yeah. I'm like, wait a second here. So this is a 4. All right, so it goes through 0 and 4. Now let's see, does it bounce off of 0 and it crosses through 4, where this one crosses through 0 and bounces off of 4. So this is going to be F. For this one, this is going to be x squared and x squared. So this is going to be x to the 4th. So it's going to be going in the same direction because of x to the 4th. The positive tells us that the right-hand side goes up, and since it's even, the left-hand side goes, it matches. Okay. Now let's go ahead and find the zeros. We have one 0 at negative 4, and the other 0 is a little bit of a trick. Because the x squared is not on the outside, so this actually has to be factored a little bit more. So let's go ahead and factor this. So this will be x squared minus 1. This factors out as a difference of squares of x minus 1 and x plus 1. That's a difference of 2 squares. So we have the solution here of 1 and the solution here of negative 1 and the solution here of 4, of negative 4. So this one actually has 3 solutions. They both go up. The 4 here is going to be a bounce, and both of these are crosses. All right, so which one's, so it's either going to be this one or this one, because those are the only two that have that end behavior. This one is the only one that bounces off of 4 and crosses the 1 and the 1. This tries to bounce off of 2, but it doesn't even have all of the solutions. So it's got to be letter D here for this one. So it's just a trial and error process. All right, you guys try letter B. Go through the process of each one. easier for you to do polynomial elimination. I don't even think you need to find all 4 elements. You can just say, what's the end behavior, rule it down to 2 items, and then find zeros. Because I believe this will be part of the non-calculator section. So you can't just pump it into your calculator and check it. All right, these are the values I got for this problem. I got negative 3x cubed with this end behavior. So with this end behavior, I know it's going to either be D or C, because the other ones don't have that. So now we just have to find out from the solutions which one it could be. This one only has 2 solutions, and I found 3 solutions. So I'm going to lean towards C being the option. And all of these, by the way, are crossing, which matches up with them crossing here. So I'm going to say that this is probably a C. Okay, on this guy over here, the end behavior is going to go to the down on the right-hand side because it's negative, and then it's going to go both in the same direction because it's an even end behavior. So we're going to be able to eliminate this down to just A or F, because those are the only ones with that end behavior. To find out which one it is, we're going to have to factor this. So negative 4x to the 4 plus 8x to the 3. We'll pull out a negative 4x to the 3 on each of these. Negative 4x to 3, negative 4x to the third. So negative 4x to the third, and what's left here is just x minus 2. So 0 and 2 are your solutions, and both of them have an odd multiplicities. This has a multiplicity of 3, so it crosses. And this has a multiplicity of 1, so it crosses. So it's going to cross on both of them. So of A and D, which one has 2 crosses? I'm sorry, A and F, which one has 2 crosses? F does. All right, identifying the minimum degrees. Okay, so we've gotten past the hard part. Let's take a look at the final part here. So identifying the minimum degree. So the minimum number of degrees is always the number of local extremes plus 1. So if I look at the graph, I can find out what the degree is. I don't have to see the equation. I can just find the degree out by finding the number of local extremes, 1, 2, 3, and adding 1 to it to get a fourth degree polynomial. This right here is a fourth degree polynomial. In fact, it's going to be a positive fourth degree polynomial because fourth degree means the end behavior is going to be both going in the same direction, and positive means the right-hand side's up. So this will be a positive fourth degree polynomial by the direction. So we'll go positive fourth degree. And I know that just by the end behavior, but the number of degrees is depending on the number of curves, number of local extremes, that is. All right, there are additional possibilities that we have to pay attention to because there is a thing called imaginary. And imaginary numbers always come in two. Imaginary numbers always come in twos. So we won't be able to visually see the imaginary numbers, and so we just have to hypothesize that there's going to be either 2 more, 4 more, or 6 more, or any, I guess, multiple of 2 past the 4. So I said right here, the number of local extremes is 3, so the degree is a fourth. We already talked about that. But if you include the imaginary options, you get not only just 4 from the real options, but 6, 8, and 10 are also viable options because there could be any number of imaginary numbers in this thing. All right, here it says, answer the following questions about the graph. First question here, over which interval is the function increasing? So if we look at this one here, it looks like it's mostly flowing down, but there are sections in here that are increasing. It looks like it's increasing from -8 to 4. So it's increasing into there. And then it also is increasing from 3 to 8, right there. So it's increasing right in here, and it's increasing right in there. All the rest of the sections are decreasing. It says here, at which value of x does the function have local minimums? So it looks like we're going to have a local minimum here at -8 and a local minimum here at 3. So we have 2 local minimums. And when we talk about where they're at, we always talk about where they are relative to the x-axis. All right, looking at the end behavior, what is the sign of the leading coefficient? Well, the leading coefficient's positive or negativity has to do with what happens on the right-hand side. So if the right-hand side is going down, what is going to be the positivity of it? Negative. And then the last question, which of the following are possibilities for the degree of the function? Now it's saying possibilities, not just exactly what you see, but the possibilities. So we have to count the local extremes. There's 1, there's 2, there's 3, there's 4. So there are 4 local extremes. According to what it says up here, it says add 1 to that, and that gives us 5. So for sure 5 is the real option, but what are other options if we include possible imaginary numbers? So 5 plus 2 gives you 7 or 9. Or 11 if they had it. It's just they come in pairs, and so it's just going to be every 2 numbers above it. All right, you guys do the last one. All right. Okay, over which intervals is it decreasing? It looks like it's going to be decreasing from 6 to 4. Or it looks like 6 to 3, so right in there. And then it's also decreasing out here, where it goes from, looks like 1 to negative infinity, so it's this guy right there. At which value does it have a local minima? It's this guy right there, so it's going to be -3. What is the sign of the leading coefficient? Well, that's always dictated off the right-hand end behavior, so since it's going down, it's negative. And then which of the following are the possibilities for the degree? Well, the degree is going to be the number of local extremes, which is 3, plus 1, which is 4. So this is the number of real solutions. All right, real degree. But then it also could be 6, 8, and I guess 10 if that was an option. Okay, those are the ones.